I'm going to do this in a little different format today because I want to feel like I'm a teacher up here. So I want to write things on the board like I'm a teacher. I want to do all these things like I'm a teacher. Okay, so we're going to go through this final exam study guide for first semester. Number one, it says classify each of the following conditions as a physical property or a chemical property. Basically, if you have to destroy it to test it for this thing, then it's a chemical property. If you don't have to destroy it, it is a physical property. So A is silver conducts electricity. Silver conducts electricity. That's physical, right? I'm not destroying it to put electricity through it. B, when aluminum is added to acid, so I want you to think about this. You're adding a metal to acid and a gas is given off, and the aluminum disappears. That is a chemical property. If I add aluminum to HCl, by now you should know how to predict the products of this. What am I doing? Plus H2. There we go. I'm not balancing it, not right yet anyway, but that H2 gas is the gas that's given off. You absolutely have to destroy that compound, so that is C, chemical, and then C. Sugar cubes disappear when added to warm water. Dissolving something doesn't mean that a chemical reaction occurred. It just means that it disappeared in solution. So sugar cubes disappearing when added to warm water, that's a physical. D. I guess I should do these in the way they do it. Mercury's density is 13.6. Do I have to destroy mercury to measure its density? No. The answer is no. That is a physical property. E. Gasoline burns in an automobile engine. That combustion is most assuredly a chemical property. Water freezes at 0 degrees. Yep. Water freezes at 0 degrees. Does it cease being water? No, it does not. So that is physical. So you are PCP, PCP. All right. Number 2. Classify each of the following conditions as a physical change or a chemical change. Now, we talked about the indicators of a chemical change, which they have below that on number 3. So let's just refresh ourselves about what those are. That is a permanent color change. Permanent color change. Sorry if I misspell stuff. 2 is odor. 3 is gas given off, gas created. We'll just say gas created. 4 is a precipitant. A precipitate is a solid that forms in liquid. I'm going to go ahead and give you a definition. And liquid. Hopefully the camera will pick this up. 5 is a change in temp. And that can get colder or hotter. So if I have a beaker and it gets warmer, that is a change in temp. If I have a beaker and it gets colder, that is a change in temp. 6 emits light. If it emits light, that is a chemical change. Like, again, glow sticks, if you snap them, there's 2 chemicals that mix in there, it emits light. So now that we know number 3, let's look through the eyes of number 3 and look at number 2 and see if we can decide on an answer. Number 2A, ice melting. Well, again, it's still ice, right? So that's a physical change. Number 2B, yeah, this is 2. 2B, milk sours. Okay, it gives off an odor, right? It also goes from a liquid to a solid. So there's a phase change there, but we're not so concerned about that. More importantly, what's happening when milk sours? Like bacteria is getting at it, something is happening there. That is absolutely a chemical change. C, sugar dissolves in water. Physical change, we've already discussed dissolving. D, a tire is inflated with air. There's nothing chemical going on there. That's physical change. E, food is digested in the stomach. Well, there's a bunch of chemical changes going on there. It emits a gas, which if you don't remember, it comes out the other end eventually. And there's acid in your stomach. Anytime you're interacting something with acid, you're probably getting a chemical change. F, water is absorbed by a paper towel. Has the water changed? Has the paper towel changed? Can I wring the paper towel out of the water? Absolutely, that is a physical change. So the answers once again are PCP, PCP. All right, and we've given the answers to 3. Those were the physical and chemical or chemical change indicators, chemical clues or evidence that a chemical reaction has occurred. 4, when a metal reacts with acid, a gas is produced. So that is, for number 4, the first blank is gas. This is an indication that a chemical reaction has occurred. Yeah, anytime you see H2 on this side and it's not on this side, you know a gas was produced. Or Cl2, or any of the things that are in red on the periodic table to let you know they're in gas phase. Oxygen. If oxygen is emitted, it's gas, right? Okay, that's number 4. Number 5. When substances react and a solid is produced, this solid is called we've gone over this, a precipitate. A precipitate. That's the little solid that comes out. Basically, you'll mix 2 liquids in a beaker, and then you'll see a solid start to form, and then it'll look like snow, and then it'll collect at the bottom. And you can filter that out. And it just appears out of nowhere. Hopefully we can do a precipitation reaction at some point. So 5 is precipitate. 6, by looking at a balanced chemical reaction, how can we tell the reaction has taken place, that a reaction took place? For example, given the reaction CdSO4 plus K2S goes to CdS plus K2SO4. How do we know that a reaction has taken place? Well, just by looking at the reaction, I can tell you for a fact, oh, by the way, they give you some more clues here. They give you that this is aqueous, and this is aqueous, and that this is a solid, and that this is aqueous. So basically what it's saying is I mix 2 liquids together, and a solid precipitated out. But more fundamentally than that, looking at this reaction, there's a rearrangement of my compounds. It's no longer CdSO4, it's CdS. I had to break a bond to make that happen. I had to reunite a bond to make this happen. So that is the definition of a chemical change, is either breaking or creating a bond, right? Or I could say a precipitate was created. Really, I mean, just looking at a reaction, you should know that it's a reaction. Hopefully you'll know if there's a rearrangement or not. But for that one, maybe they were looking for a precipitate was formed. Anytime you see 2 aqueuses on one side, the little things in the parentheses, AQ, X, and Y, AQ in parentheses, and it goes to XY, which is a solid, and then maybe something else. Then you'll know that if I had liquids over here and a solid over here, the precipitate was formed. Okay. 6. Oh, they wanted me to, oh my god, and I erased it. So CdSO4 plus K2S goes to CdS plus K2SO4, aqueous, solid, plus aqueous, aqueous. it says, list the reactants, A and B. Well, there's A and B. State of matter for A and B is going to be liquid, liquid. I know this because of that aqueous symbol. List products, P, P. Anything on this side of the arrow. Anything on that side of the arrow is a product. States of matter, solid and liquid, as evidenced by the little s and the little aq. So the precipitant in the equation is CDS, because it's that solid. Okay, hopefully everybody gets that. Basically, this is just asking you if you know what those little symbols mean and whether you know what a reactant and a product is. All right. Given the reaction of Zn2HCl, Zn plus 2HCl goes to ZnCl2 plus H2, how do you know the reaction took place? Well, H2 is a gas, so gas was emitted. Gas was created. How do I know that hydrogen is a gas? It's in red on the periodic table that's going to be in the room with you as you take your final. All right, given the reaction, okay, that's the answer there. Gas was created. Number 8. Given the reaction 2C2H6, 7O2, goes to 4CO2 plus 6H2O plus heat, how can you tell a reaction took place? It's the end of it where it says plus heat. One of the indicators was a change in temp. If it says plus heat on the product side of the arrow, if you have whatever you have on this side plus heat, heat was created. That's a change in temperature, right? So that's how I know a reaction took place. So that's number 8. Heat was created. Okay. Number 9. You are given the following information about a sample. What piece of data can you use to identify the subject? Well, length isn't going to give me anything. Mass doesn't really tell me anything. Density and state of matter tell me a little bit. So really, the piece of data, which piece of data would I use? It would be density. Because every compound and every element has a unique density. Now, it may not vary by much. It may be 10,000ths of a gram per milliliter, but everything has a fingerprint, has its own density. Just like everybody in the room would have a different density. Because you weigh different, you displace different amounts. You have different amounts of muscle. So yeah, number 9, I would use density. A sample has a temperature of 50 degrees Celsius, has a mass of 5 grams, a density of 2.1 grams per milliliter, is silver in color, and a volume of 2.38. Which piece of data could be used to identify the sample? Well, again, density of 2.1 grams per milliliter is going to be what I would use. So number 9 and number 10 are both the same. Again, it's going to have a unique density. Density of 2.1 grams per milliliter is going to line up with some material or another. I asked you this one in class. What is the density of water? It is not 1. It is 1 gram per milliliter or 1 gram per centimeter cubed. So that is 11. Well, a substance with a density of 0.5 grams per milliliter, sink or float. If it has 0.5 grams per milliliter, that is less than 1. Anything less than 1 is going to float on top. Anything greater than 1, so if it's 0.9, and I'm going to draw it this way. This is water. 0.9, 0.8, 0.7, 0.6 grams per milliliter. Those are all going to float, whereas 1.1, 1.2, 1.3 grams per milliliter. If it has a density of that, it's going to sink. If it's greater than 1, it'll sink. If it's less than 1, it'll float. And you can put them in order. They would actually actually be in this order that they sank. If I put three objects with three different densities and they're 1.3 grams per milliliter, 1.2, and 1.1, let's say I put these liquids in, you would have distinct layers in this graduated cylinder. And the 1.3 would be at the bottom, the 1.2 in the middle, and the 1.1 at the top, nominally with water filling up the top as 1 gram per milliliter. Just put it in order. That's all there is to it. Very simple. Okay, multiple choice. Determine which will float. Well, there's only one answer there that makes any kind of sense at all. Density of 1.6 grams per milliliter. We don't need to look at the other information. 35 milliliters of volume, doesn't matter. All we care about is its density. Okay, 1.6 grams per milliliter, that's going to sink. A is going to sink. Density of 0.97 grams per milliliter, that's going to float, so B is going to float. C, 3.5 grams per milliliter, sink. D, 1.1 grams per milliliter, sink. So there's only one that's less than 1, and that's B. A lot of y'all missed that when we were doing the boards in class. So please, please, please get that through your head. That if it's greater than 1, it'll sink. If it's less than 1, it'll float. Water is at 1 gram per milliliter. Okay. 14. A student was given an irregular object with a mass of 42.3 grams. Okay, so we're going to write all our information down as we go, 42.3 grams. And I recommend you do this on the final, too. Write down the information that they're giving you. An initial volume of, given an irregular, I don't like how that's written. After placing the object in a graduated cylinder with an initial volume of 25.4 milliliters, so I've got a graduated cylinder here. And initially it had a water volume of 25.4 milliliters. And then I put my object in, whatever it is, whatever irregular shaped object. Dropped it in there, and as soon as I dropped it in there, it went up to 65.4 milliliters. So in order to do a density calculation, I need the volume of this object. Well, whatever our displaced volume was, that's what the volume of our object was. So however much change happened here, that's what our volume is. So how much change happened here? Well, 65.4 minus 25.4 equals 40.0 milliliters. And guess what? This is the equation for density, right? So, on 42.3 divided by 40 equals 1.0575. 0.0575 grams per milliliter. And determine if the object will sink or float. Is it greater than 1 or less than 1? It is greater than 1. It is definitely going to sink. All right, I got to end this first video, and then we will start the second video in just a minute.